In this example, we're asked to try to find a vector field G on all of R3, for which the curl of G is given by this vector field right here. So you might call this vector field F if you want, and let's do that. Why not? So this vector field here, this is our given vector field, call it F, and we want to find a vector field G for which F is the curl of G. F is equal to the curl of G. All right. Now, as always in mathematics, it would be a waste of our time to try to solve this problem if no solution existed. So the first thing we should do is verify that this problem even has a solution to begin with. So I'm going to write this as following. Existence question mark. So in other words, I'm asking myself, this is a typical mathematical question in this scenario, does a solution to this question even exist? Okay? And we have a tool, we just developed a tool actually, to check whether or not it's even possible. You know, we can't necessarily say for sure that we have an answer, but we can check if it's even possible to have an answer. And what we showed in the last theorem and example is that the divergence of any curl field, okay, the divergence of any curl is always equal to 0, okay? So if a vector field G exists, for which its curl is given by this, the fact that this vector field F is a curl of something else would have to then imply that the divergence of F is equal to 0, right? So for us, the way we're going to interpret this is that supposing there is a solution to our problem, then the divergence of our given vector field must be 0, okay? Is the divergence equal to 0? We're not sure, so let's check it. So remember, the divergence is the sum of the component-wise partial derivatives. So the divergence of what I'm calling f here is equal to the x partial derivative of x sine of y plus the y partial derivative of cosine of y plus the z partial derivative of this function, z minus xy. Okay, and let's compute. Again, after computing the partial derivatives and adding them up, we should get 0, hopefully. Let's see what happens. We compute partial derivative with respect to x of x sine of y. That is just sine of y. Sine of y is a constant here. Derivative of cosine with respect to y, cosine y, is negative sine of y. So far, so good, right? But what happens when we get over here? The z partial derivative of z minus xy is 1. When we add this up, we get 0 plus 1. That's 1. 1 is not 0, right? So I'm tempted to put a frowning face, but actually, you know, what does this tell us? You know, as long as this is correct, what this tells us then is that no vector field G exists, right, for which the curl of G is this function f, this vector field f. So this vector field, this given vector field, cannot be realized by the curl of any vector field. All right, so this is a useful check here. So the vector field G cannot be realized, sorry, the vector field F cannot be realized, the given one, cannot be realized by the curl of any other vector field because it is not divergence free.